Hi everyone, welcome back to chemistry. In this video, we're going to talk about concentration. So in lab, I often will tell you the concentration of different solutions that we're using molarity. So you'll see, 1m or 2m on the board right next to, HCl, hydrochloric acid, or something like that. And what that's telling you is how concentrated that solution is, how much solute is dissolved in that solvent. And the more solute dissolved in a given amount of solvent, the more concentrated that solution is. So for instance, 1 molar hydrochloric acid is less concentrated than something like 3 molar hydrochloric acid. And while you need to be careful with both, 3 molar hydrochloric acid can do more damage, right? Very quickly. So because it's more concentrated. So we need to talk about concentration a little bit. But there are lots of different ways that we can express concentration. Molarity is one of them, right? That's here. We'll talk about that more in depth in a little bit. But there's also stuff called percent composition. And there are several categories of this percent composition. And that's mass by mass. That's how you say that out loud, mass by mass, volume by volume, and mass by volume. And so we'll talk about what each of those means in more depth. But these are all just different ways that we can express the concentration of a solution. So the first one I want to talk about is one of our percent composition ways of describing our concentration, and that's mass by mass. So the mass by mass percent, sometimes denoted like this, percent mass or m/m, is defined as the mass of a solute divided by the mass of a solution and then times 100. Just like in our percent yield calculation, there's a times 100 at the end. That's just to get it into the percent form, because we're going to be dividing and we'll get a fraction out of this number here, and then we multiply by 100 to put that decimal into a percentage. So like this says above, we take the mass of our solute, right, the thing we're dissolving, and we divide that into the mass of our solution, our total solution. Now remember that solution, when we use the term solution, that's the solute plus our solvent, right? So for NaCl solution, right, that's the mass of our solute, NaCl, for example, plus the mass of our solvent, water, for example. And for mass by mass percent specifically, we're going to take the mass of our solute plus the mass of our water, and that's going to give us the mass of our solution. So don't be fooled. When I say mass of solution down here, I'm talking about the mass of your solute plus the mass of your solvent. That's going to give you the total mass of your solution. So this number here is what goes here. Okay, so let's try this out, and it'll make a lot more sense when we try it out. So this says a saline solution with a mass of 355 grams has 36.5 grams of NaCl dissolved in it. What's the mass by mass percent concentration of the solution? All right, so it says, let's break this down a little bit. It says that we have 36.5 grams of our NaCl. So what's our NaCl in this example problem? Is that our solute, our solution, our solvent? Yeah, that's our solute. That's our solute, the thing that we're dissolving into water to get our saline solution. So that's our solute. So that goes here. And then what's the mass of our solution? Well, that was given to us, right? It says a saline solution with a mass of 355 grams. So that goes here. So in order to calculate this, let's copy this down here. We have the mass of our solute over the mass of our solution, and then times 100. So percent mass by mass composition is 36.5 grams of NaCl over 355 grams of saline solution. I'm just going to put saline solution here. Now notice that our units are grams and grams. So I have those written here in our equation. That's really important because later we're going to have different units, right? For different, mass by volume or volume by volume and stuff like that. So we want to keep track of our units. Okay, so let's get a number out of this. So it's 36.5 divided by 355. And I got 0.1028, but remember we have to multiply that by 100. So that's going to give us 10.3%. So what does this number actually mean? Well, it means that 10%, around 10% of this solution is sodium chloride. That's the concentration of sodium chloride dissolved in our solution. And when we think about this kind of conceptually, looking at this, this part right here that I've circled, we have the mass of our solute, the thing that we're dissolving, and the mass of our total solution. And what that gives us is a fraction. Hey, how much of my solution consists of my solute? How much solute is dissolved in this solution, right? If you have 36.5 grams of sodium chloride in a larger amount of solution, you're going to have a less concentrated solution, right? Okay, so hopefully that makes sense. Let's keep moving along here. So the other percent composition we want to talk about is volume by volume. So just like we can use mass by mass, to figure out the percent composition or describe the percent composition or the concentration, we can use volume as well. So for gases and liquids, volumes are much easier to measure than for solids. So the concentration of a liquid or a gas can be expressed as a volume by volume percent. And this is the volume of a solute divided by the volume of a solution. And then you multiply by 100 to get into the percent form. So same idea here, right? How much solute is dissolved in a given amount of solution? Again, remember that when I say volume of solution here, I'm talking about the total solution, okay? So you're going to have to take the volume of your solute and add the volume of your solvent, okay? All right, so let's try this out. So this says an 8.4% volume by volume solution of methanol in water has a total volume of 450 mils. What is the volume of the solute? Oh, so in this case, we are actually given our percentage over here, and the total volume of our solution here. And now we've got to solve for, let's color code that. We'll put the thing we're solving for in green. So let's write this down here. So percent volume by volume equals volume of solute over volume of solution times 100. And now it even tells us that the solute is methanol here. It tells us that. So we want to know, well, how much of our solution of methanol in water is just methanol, right? Okay, so we've got our percentage. So let's put 8.4 over here. And that equals the volume of our solution or of our solute is what we're solving for. So actually, I think I'm just going to call that X for now. And then I'm going to put all of that over 450 mils, which is the volume, the total volume of our solution. And then we got to multiply by 100. Okay, so let's get rid of that multiply by 100 part, this part over here, because we want to get X alone. So in order to do that, we got to divide both sides by 100. So we'll divide both sides by 100. That's going to put that percentage back into a decimal. So 8.4 divided by 100 is 0.084, and that equals X over 450 milliliters. Now again, we want to get that X alone, so we got to multiply by 450 mils And whatever we do to that side, we got to do the other side. So let's get rid of that. And now we can multiply by 450, and that's going to give us x equals 37.8. And then what are our units here? Milliliters. Okay, and now I'm just going to replace x back with the volume of solute, in this case methanol, equals 37.8 milliliters. All right, the third percent composition we use is mass by volume. And this is often commonly used for intravenous fluids. And it's defined as the mass in grams of a solute divided by the volume in milliliters of solution. So this is useful for when we're dissolving a solid into a liquid. And just like before, we have a handy-dandy equation. I forgot to mention above that any of these equations for your percent compositions and stuff like that, they're all going to be given to you on an equation sheet for your exam. So you don't need to memorize them, but you do need to know how to use them and when to use which one. So don't memorize it. You can if you'd like, but you don't have to. It's not required. Okay, so let's try this out. A normal saline solution contains 9.1 grams of NaCl in every liter of solution. What is the mass by volume percent of normal saline? Okay, so again, this time, just like the first example we did, we're solving for this percentage. So we'll go ahead and figure this out. So let's write this over here. So mass by volume equals mass solute over volume solution. This is in grams and this is in mils times 100. All right, so let's see, what can we plug in here? Well, I'm noticing that we have 9.0 grams of NaCl, and then we have 1 liter of solution. So the NaCl is our solute, and I know that because it's expressed with a unit of mass, grams. Okay, it's also a solid, and I know that because I'm familiar with sodium chloride. And then I knew that we had a liter of solution because in every 1 liter of solution, we have that right here, there are 9 grams of NaCl. So I only know my volume of my solution in liters. But this specifically asks for volume in milliliters. That's the convention for this percent mass by volume for these calculations. So if you're given liters, you have to convert to milliliters. But that's okay. We know how many milliliters are in 1 liter. There are 1,000 milliliters in 1 liter. So if we have 1 liter of solution, we have 1,000 mils. So let's go ahead and plug in these numbers. So we have 9 grams of NaCl divided by 1,000 milliliters. Again, putting my units in there, right? And then we got to multiply all that by 100 to get it into a percentage. So we're essentially taking 9 divided by 1,000 and then multiplying by 100, which is going to give us 0.9. And let's go one more sig fig for that. 0.90% is our percentage, or our mass volume percent for normal saline. All right, I'll see you in the next video to talk about molarity.